Okay, here in part 3, we have a radio that's been recapped, it's been aligned, it's working properly, but there are some complaints about a high hum level, some other minor complaints like switching and noise with contacts, that kind of thing. But really, the major thing we'd like to take care of is safety and getting a proper cord on the receiver. So in this part 3, I'm going to be doing the standard single cord, no isolation transformer modifications. 90% of the radios and 90% of the people that are taking this on will do this particular update. It makes the radio safe, reestablishes proper isolation, and you end up switching properly and getting the outer part of the case grounded properly. So here we go in part 3. Let's make the S-38A safe. Okay, so I have removed the first grommet. It's really not too bad. This one's in pretty good shape, actually. And I've replaced it with a McMaster car. This McMaster car has a smaller diameter inside. This is a much better grommet for the job. So all 4 of the grommets are going to be replaced. The shape of the grommets coming out, they're still in better shape than I would think they would be in. You know, they're destroyed partially from taking them out, but you still got a lot of rubberiness to them, I think. They're not bad. I would have expected these to be in a lot worse shape than this. They've all been replaced. I've got the nylon screws and nuts in place. I'm using regular metal washers on them because that's not the part that is going to cause a short, and that makes sure the compression is correct. I've replaced the 2 back washers as well. Now I know why we had hum even with the switch off. He's coming in with the cord, going through a fuse, and then going right into the isolation transformer. On the other side of the isolation transformer, on the secondary, that's what he sends over to the on-off switch. So that's kind of unusual. I don't think I've ever seen that before. I guess I see the logic. I don't think it's going to get you any advantage. Of course, he had to fuse the opposite side as well. So there's a fuse over here that he's added around the switch. The other side of the switch appears to go right to chassis ground. So he's switching the negative. I guess I don't like that either. Hey, we all have our ways of doing things, right? So I think I'm going to loosen up the transformer and I'm going to wiggle it about and see if the orientation of the transformer has anything to do with the hum. So I will be doing a hot test before I actually unsolder anything.
So what is the problem with the S-38 the way it's designed? AB1DQ lays out the shock hazard issue that we have in most AC/DC sets with this nice graphic. As you can see, the original Hallicrafter's method of line wiring, and that goes for most AC/DC sets of the era, they switched the neutral line of the AC cord to the chassis ground. That's how you turn the set on. So why do they do this? Hum. Theoretically, the neutral line connected to the switch would naturally be closest to the audio volume control, since that switch is really built right into the potentiometer. This is why they recommended that you reverse the plug to get the least hum. This is a clever system and it works. However, in this neutral switching mode, when plugged in and switched off, the radio becomes basically hot to ground in varying degrees depending on the insulation quality, everywhere, on the chassis, on the outer case, whatever. Connected to ground and touching the metal cabinet or any exposed metal on the radio while it's plugged in could produce anything from a slight tickle to a potentially fatal shock. So the original neutral or chassis switching is not a great idea. Of course, there was no guarantee that you even had the neutral on the switch side to begin with, because you didn't have a polarized plug. We need to switch the hot lead, but you really have to know which lead is the hot lead. This starts by testing your outlet and making sure it's wired correctly. Then a polarized cord is used to replace the original cord. Go further. Use a 3-wire cord. That adds even more protection. If you connect the green wire to the outer case and you have a well-wired modern outlet, you're going to be in better shape than any other type of cord. So this first method I'm going to do, the insulation in this radio is done with rubber grommets. We're going to rewire that power switch, and we're going to use a 3-wire cord. I'm going to assume that you've already done the basics. In other words, you've done a basic recap, but one more capacitor issue needs to be discussed. Let's discuss the chassis to case capacitor. In the S-38B, this is C36. They put in a 0.25 400 volt paper capacitor. Sometimes people like to call this capacitor the death cap. I thought the death cap was a mushroom. This capacitor can become leaky or even short over time, thus connecting the potentially hot chassis to the outer case. So during your recap, you would have replaced this probably with a 0.1 to 0.47 microfarad 400 to 630 volt Mylar. That's an excellent choice, by the way. But we can do better now. In the 21st century, we now have safety capacitors. These fail in predicted ways. In this application, we can now install a capacitor that fails open rather than shorted. So this is the new safety standard, and you'll see these in your ATX computer power supply and in modern radios and stereos. So let's do this. Let's do what I'm calling Method 1. That's doing all of the updates on the safety components inside the radio and using a nice 3-wire cord. By the way, this non-isolation transformer approach, which involves basically replacing the grommets, a recap, rewiring the switch, adding a fuse or two, and a new cord, is by far the most practical and popular method for the S-38 series. It gives excellent protection into a known outlet. Basically, for the next 35 years or so, that radio is going to be fine. Of course, components again begin breaking down almost immediately.
To make the receiver safe with a standard 3-prong plug, I've got a nice 9-foot power cord. It's a 16-3 cord. I've got a nice Hayco grommet that I put in the back of the radio. So that's a starting point, starting with a good 3-wire cord. With this cord, we're going to do a safe way to wire the radio with no isolation transformer. So we're basically going to be rebuilding the safety features in the radio. That is, replacing the grommets that provide the isolation between the inner chassis and the outer case. This is a hot chassis radio. One side of the line is actually switched to ground. So they take the neutral part of the cord and they run it to this switch. And when you turn the radio on, you're connecting neutral to the chassis. And of course, if the cord is switched, okay, in the old days they didn't have polarized plugs, that means you're going to get a hot chassis pretty much no matter what you do. This is a dangerous situation that has to be corrected. So we can fix a lot of that by using just a 3-wire cord. The neutral, we will instead wire directly to the chassis. The hot is what we're going to switch, the hot wire. And the green wire is going to go only to the outer chassis. That guarantees that you can't get a shock from the outer case. You can still get a shock potentially if your outlet is miswired and the hot and neutral are switched. The chassis would again become hot, but you'd have to work for it to get a shock. Okay, I'm going to show you the baddie. This is the place where this radio really breaks the rules and it needs to be corrected. This is the on-off switch on the back of the volume pot. This is your main on-off switch. Let's zoom in. This side of the switch is coming from the AC cord, or what was the AC cord. he's put a fuse in there. So that's a fused input off the line. Over here, this terminal is the one that goes down to ground. I've already removed the wire that attaches it to the ground point. I'm also going to remove the fused connection that goes to the neutral of the line over here on the 35Z5. So this side of the switch, he's got a fuse in line that goes over to the 35Z5. That line is going to be switched over to the other side of the 35Z5. It's going to go to the hot part. So that's going to be the input to the rectifier. Right now it's switched to ground. Now it's going to be the hot wire. That's this black wire here. This black wire is going to be wired to the switch through the fuse. And then the other side is going to go to the input of the rectifier. Now I'll have some capacitors to ground and some other features in there to do some filtering. But you get the idea. We're going to switch hot now instead of switching the neutral to ground. Switching the neutral to ground is a dangerous situation. You want the neutral connected to ground. You want this white wire connected directly to the chassis. You want to switch the black wire. In Europe, this is a blue wire. The green wire, on the other hand, you want to go to the outer chassis. These floating switches, for instance, are attached to the outer chassis. If I connected that here, as soon as I put that case on and screw the screws in, this will guarantee that the outer chassis is grounded, making it very difficult to get a shock off this receiver. You'd have to somehow get a hold of the chassis, and the AC cord or your outlet would be miswired. So let's get this wired up correctly. And I put a nice terminal strip over here. This is where I'm going to put some protective components for the line, where I'll put the fuses and so on. It'll be along this terminal strip. And this will be the no isolation transformer safe wiring of the radio. I've already replaced the grommets, both here and here, and I'm using non-metallic screws on the grommets up front. So we've done a couple of things to make it better than factory wiring. We are now switching hot instead of ground, and we now have a grounded outer case. So those are two improvements over the original safety system in the radio. Let's go through the modern safety capacitors that you'll find on common power supplies that are in use. This is an old power supply out of a Dell computer. And as you can see, there are many components in there that look like capacitors. But the ones I want you to focus on are the two blue ones that are connected from line neutral and line hot to ground. Line neutral and line hot to ground. Those two blue capacitors right on the input of the IEC connector, they represent capacitors that if they shorted could cause trouble. So they're specially designed that when they take a surge and fail, that they fail open. Those are called Y2 capacitors. Generally they're blue, not all the time, so you have to check the markings. The yellow capacitor that's on the board is directly across the line. That capacitor is an X2 capacitor. This is a capacitor that if it fails, you would like it to short as its failure mechanism and blow a fuse or open a thermal fuse. So the yellow capacitor is designed to short. That's an X2 capacitor. It goes across the line. These are typical X2 and Y2 capacitors. Again, the X2s normally are yellow. The Y2s normally are blue. So just to bring it home, this is an input filter. This is an actual module that you can buy that gives you 2 stages of filtering. And it's a double pi circuit on the AC line, I think this one is rated at around 10 amps. This little device, you just stick this inside your unit that you're building, and it provides excellent RFI protection. You'll notice that there are some blue capacitors in the middle. These go from line to ground, and these are labeled CY2. So they are Y2 capacitors, these little blue guys. There are also some gray capacitors right across the line, and those are marked as CX, CX1, CX2, and CX3. So these are the X2 capacitors that are across the line. Again, the CY2 capacitors, when they blow, they open. When the X-style capacitors blow, they short in order to pop the fuse. I also found an outlier here. This is an X2 capacitor, but it's blue. The X capacitors normally are yellow, but they can be gray or blue. But most of the Y capacitors are blue, but don't confuse them with ordinary high voltage capacitors, which are also usually blue. A word of warning on these protective filters. These filters are great to take the noise out of a switching power supply that's transmitting up the line. You know, a solar charger, battery chargers, anything that makes a lot of noise, these input filters can keep that noise from getting on the line. They're great devices. But do be careful with them, because the capacitance that they put across the line, along with the inductors, and these are common mode chokes, they can fool some GFI outlets. So some of the outlets in your house could get fooled during the machine's operation, or even just the act of plugging them in, could fool your GFI outlet into thinking that there's a ground fault. It sounds backwards, but that's what happens. You try to protect something and you end up tripping some other safety device. So next, let's get those wires in place. Here is the initial wiring on the power cord. I've got a 5-terminal strip that I've added here. Everything is floating, nothing is grounded yet. The hot from the power cord goes through a fuse to this terminal. The neutral from the power cord goes through a fuse to this terminal. The X2 capacitors across the line in neutral, which are fused. And the 2 Y capacitors are to the ground in the middle, to each of the hot and the neutral posts. A green wire comes off the ground, okay, and goes up to the front plate. That front plate will screw on to the outer box, and that's how we get our overall box ground. Nothing is connected any further than this. This is just the fused, protected filter capacitors on that strip. From these points, we will be wiring to the power on-off switch. We're going to take the hot wire and we're going to run along the chassis all the way to the switch, back from the switch to the 35Z5. And the neutral, okay, the neutral wire is going to go, you know, it's through the fuse. The neutral wire is here through the fuse, is going to be wired directly to the inner chassis. So just a link right here, ground to neutral. Now that's where the switching was done before, but this time we're going to be switching in the hot lead. This neutral lead also has to go over to the 35Z5's input, so there's going to be some wiring this direction as well as the direction to the on-off switch. Okay, the wiring is complete. The first thing I want to do is remove the capacitor that was put in up here. This is the original capacitor that bridges the chassis to the outer case. The guy used a 630 volt 0.22, which is a good choice. This is a plenty safe capacitor, lasts a long time. So a lot of people just stick with this and you're done. No safety capacitors. But I wanted to use the safety caps, so the safety caps are down here on the terminal strip. Now for the wiring to the switch and back, I decided to use a shielded 2-wire cable. It's pretty big and thick, but instead of having two wires going across the chassis and back with all that high voltage AC on it around the sensitive components, I'm using a shielded cable to run the power up and back from the switch. The ground side is open down here, and it's connected to ground right at the potentiometer. Remember, one of the potentiometer leads goes right to chassis ground. That's where the shield of the shielded cable goes, right to ground. So now we have a shielded AC connection back to and from the switch. Of course, one side, the side that's coming from the cord, is the fused hot lead going out, and the red lead is the return from the switch going right to pin 2 of the 35Z5 tube. Neutral is connected to ground here, from the neutral lead right to chassis ground. So that's it. That's all the modifications needed for safe powering of the set. Okay, the first configuration is completed. This is the 3-wire cord with the Y and the X2 capacitors installed. Everything came up very nicely. The hum is notably lower out of the case. I'm going to put the whole thing together so we can do a measurement like we did initially.
All other books with it. You could very well be working with a liberal government.
Okay, so there's no antenna attached.
I have to.
It's just picking stuff up through the air. Basically, this thing has so much sensitivity that in an unshielded manner, it's just picking stuff up through the air. I can tell you it's not coming through the cord because we have a very good filter on the input now. We have two 0.001 capacitors between line and neutral and ground, and we have a 0.47 capacitor, the X2 capacitor, across the line. So let's get this thing in the case and let's see what we've done to the hum situation by using a regular 3-wire cord. This is the first configuration.
That's interesting. Out of the breakfast is, Clark, you got to get yourself...
Okay, basically this is just the cord. So we haven't done a lot. Remove the isolation transformer. So let's look at what it's doing in the phones. Okay, with the volume control all the way down, you can see we've made quite a dramatic improvement. This is the 50 millivolt per division. So if we look at that closer, that's 10 per. That looks to be about 30 millivolts peak to peak. Now, it hasn't improved any of this crazy nonlinearity stuff, but I have a feeling that has a lot to do with the 35Z5. However, this is a huge improvement.
Jamaicans, and they all know me, of course, so it's like, you know...
Yeah. So this is pretty good. This is what most people would do. Put the 3-wire cord on, recap the receiver, change those grommets, and you'd be back in business for another 30 years before you start to get nervous about the grommets again. So that was method 1. I'm pretty happy with method 1. I think this is the one that most people will do, in fact. We have our safety caps in place. Not too many complaints here. I think this is a very effective way to go. Let's do our close hum test. First of all, with the volume, with the unit off. Okay, with the unit completely off, we'll put the microphone down on the speaker. Okay, no more residual hum, I hope. Now let's turn it on. And I'm going to disconnect the antenna. We've now got the Antenna disconnected, and the volume is all the way down. So let's try to listen to the hum. Now I'm going to put the volume all the way up. AM mode. Volume all the way down. Okay, hopefully we could hear the difference between this configuration and the original isolation transformer configuration. So that's as far as I'm going with method 1. So am I satisfied? Well, of course I'm not satisfied. We need to get the hum even lower. Plus, we need to investigate these isolation transformers over here and see what else we can do with this radio to tame the hum situation. I have improved other things that were asked for. For instance, I've shortened the shaft by about 1/8 of an inch to make those 2 knobs go on the front panel in an even manner. Be careful with that. You can make some fine adjustments on the back plate by bending it forward and backward to extend or retract that shaft, by the way. So just be careful around the dial string. It's tricky. So stand by for part 4, where we go into the hum a little bit deeper, and then we do the isolation transformer conversions.